Welcome to Mrs. Miller's Math Show. It is Monday. We are all very, very tired, so we are going to take a break from the normally scheduled game show format. We're going to have sleepy notes today. Let me show you they're all resting their eyes in preparation for a really wonderful lesson. Here we go. You all can see what's happening. Everybody wake up! Wake up! All right, here we go. Let's try to get a little bit of cheer out to try and just, everybody make some noise. Woo! All right, here we go. So we're skipping the super notes for today. Ready? Here we go. So everybody, that is your cue to stop talking. Here we go. Today we are talking about equations of lines. So we've looked at this a little bit, but here's what I want to start out with. You don't actually have to write this part down. Make sure we're actually recording. Okay. The number 5 is the number 5. I can write the number 5. You don't have to write this part down. I can write the number 5 as 10 divided by 2, right? That's a divided by symbol, not a... Right? Can somebody tell me another way I can write the number 5? Thane.
4 plus 1.
Good. 4 plus 1. Can someone tell me another way? Just work with me here. I know we all think this has nothing to do with what we're doing, but Alyssa?
6 minus 1.
6 minus 1. Good. What else?
3 plus 2.
3 plus 2. Good. Deanna? 20 divided by 4, or 20 over 4. Good. Thane?
1 times 5.
1 times 5. If I do something like the square root of 25, is that 5 as well?
Yes.
Oh my. What if I do something like 1 plus 1 plus 1 plus 1 plus 1? Yeah?
That's a lot of ones.
How about 20 minus 15? Do those all represent the number 5 adequately?
Yes.
How about something like 5.0? 5.0 is not the same thing as 5. That's good. Okay, so, all right. So, you guys tell me, if a kindergartner were looking at this, would a kindergartner be able to say that all of these are the same thing? Do you think? That's not the square root, probably not the decimals even. Yeah, okay. So the moral of this story is we're going to be looking at different forms of lines. These are different forms or different ways we can express the number 5. Today we're going to be looking at different forms or different ways to express the equation of a line. They all do the same thing, they all mean the same thing, but they're just written in a little bit of a different way, okay? So y equals mx plus b is the first one that we're going to look at. Y equals mx plus b is slope-intercept form. This is the one that we see all the time. So, slope and the y-intercept. Okay, and we typically want to get our equations back to slope-intercept form if they're given to us in something else. Okay? The next one we have is point-slope form. So we looked at this one a little bit during our homework this weekend and in our last set of notes. Point-slope form. Okay, I need more room for this one. I'm going to move it down a little bit. So point-slope form is y minus y1 equals m times x minus x1. And in this one, m still represents the slope. And then x1 and y1 represent a point on the line. So remember, for lines, we can graph them. Whoops. We can graph them on a coordinate system. Okay, so these are the things that we can extract from point-slope form. But they both look different, right? In slope-intercept form, we have an m and a b. The only thing that they really have in common, well, we have the y and the x too, but the only thing they have in common is the y, x, and m. But this one has an x1, y1, this one has a b. They're a little different. Okay, so here is the next one that tends to throw people all the way off. Okay, that is standard form. Sometimes we are given equations in standard form, or the most typical way of seeing this is given a word problem, are asked to create an equation in standard form. That's systems of equations. We'll get into that in a little bit. This one just says ax plus by equals c. Okay? Where a, b, and c all represent any real number. Any real number. Okay, so just like we talked about in the very beginning, the number 5 can be represented or written in all of these different forms. Lines can be written in these 3 different forms. And we're going to take a look. And if we have a different form other than slope-intercept form to start out with, we want to get it back into slope-intercept form so that we can do whatever we need to do. Okay? Everybody have those written down?
C.
No? C? Yes? Okay. What's that? Oh, the third number. Yeah, that's all. Everybody have them? Let me pause it for just a second. Okay, so we're back with examples. Find the slope and y-intercept. Okay, we do not want to overcomplicate any of this, okay? Find the slope and y-intercept, and the first thing that we're given is y equals 2x plus 3. Okay, y equals 2x plus 3. So, again, I said that we want to get it into slope-intercept form if it's not already in slope-intercept form. If I go back, slope-intercept form, again, is y equals mx plus b. The slope is whatever number's in front of x. The y-intercept is whatever does not have an x attached to it is. So, in this one, who can tell me what the slope is? Let's see. Let's have Shuggy. 2. Good. It is whatever number is in front of the x. Good. Who can tell me what the y-intercept is? Vanessa? 3. Good. It's whatever does not have an x attached to it is. Questions? The end. Don't overcomplicate. Questions on that? Let's do another one. Y equals 6 minus x. I'm actually going to put this in true slope-intercept form. True slope-intercept form, we want to put the x first and anything else after it. So I'm actually going to keep the negative with it and just rewrite this as negative x. This is a positive 6, so plus 6. So from here, can somebody tell me what the slope is? Tyler.
-1.
Good. -1. Okay, I don't see a 1 there. How did you know that it's -1?
Because it's just x and x is 1.
Good. There's just an x, there's an invisible 1 in front of it. You don't need a 1 in front of it to know that you only have one of them. Alyssa.
6 is B.
Good. 6 is the y-intercept or b. Perfect. All right. Pretty straightforward. Okay, we have 2 more. I know you all love these. They're actually waiting to be done so they can take their little naps at the end. We're not actually taking naps. I shouldn't say that. We're not. But these are being posted, and I want to make sure that we are abiding by our school rules. If you all slept, I should put a little disclaimer on it, like at the bottom that says, do not try this at home. We're actually not sleeping. Okay, 5x plus 2y equals -7. Okay, so what did I say before? If it's not given to us in slope-intercept form, Sloan, what do we do? We put it in slope-intercept, good, which is putting y by itself. So how would we get y by itself? Good, subtract 5x first. Crystal, can I give you these to keep track of points? S'il vous plaît. That's good. That's the one. Okay. Okay, -5x minus 7. Excellent. Okay, so next, after that, if we want to get y by itself, Rebecca. Divide by what? No, you're right. Perfect. Divide everything by 2. So we get y equals, let's move this up, y equals -5 halves x minus 7 halves. Good. Okay, so now that's not what we were supposed to do. We were supposed to find the slope and the y-intercept. So you guys tell me slope. Can someone tell me what the slope is? Tyler?
-5.
Good. Rebecca, y-intercept? Good. All right, questions? Okay, last one of this type, and then we'll move on. Okay, so y equals 9. Y equals 9. We want to find the slope and the y-intercept. Okay, so what do we think? Do we have an x in here? No. So we have 0 x's, correct? Okay, so will you guys tell me what's the slope? Slope is 0. And the y-intercept? 9. Good. Okay, still good on questions? Yes? Okay, we're going to revisit, really briefly, we're going to revisit graphing. I know you all love it. That's my gift to you. It's graphing. Okay, y equals negative. All right, so here we go, graph. And we are graphing. The first one we're graphing is y equals negative x plus 4. Y equals negative x plus 4. All right, so let's draw a graph. This is in the correct form, so we're good. And so can somebody direct me how I would graph y equals negative x plus 4? What would be the first step? What would be the first point that I would graph? Taylor? 4, good. So we go up to positive 4, 1, 2, 3, 4, and then from there, what do we do next? We have a slope here. Taylor? Good, down 1, right 1, if our slope is negative 1. And that's it. Connect the dots. How we doing on questions? It is a snooze fest in this classroom right now. Everybody looks like they're literally going to pass out. You're ready for your... Okay, questions? We're gonna do one more of these so that you all can make sure that negative 2x equals negative 3y plus 2. Negative 2x equals negative 3y plus 2. Do you guys remember in elementary school that you used to take naps?
No, because I took it in kindergarten and preschool. I was not taking naps in elementary school, but
I miss nap time. Okay, so what we said before is that if it's not in slope-intercept form, we want to get it there. How would I get y by itself in this equation? Eventually, yes, we're going to divide by negative 3. Sloan? Subtract 2. So I'm going to actually flip this around so that I have the y on the opposite side. So negative 3y equals negative 2x minus 2.
you're supposed to add 2.
Okay, 2.
Oh.
Are you talking about this one?
Yes.
You could have done it that way. Yeah, that's another way to do it. She chose a different route. They both work equally well. Yeah. Okay. So then, last step to get y by itself. Taylor. Divide by negative 3. Good. Okay, so we have a bunch of double negatives here, which makes them what? Positive. So we end up getting y equals positive 2/3 x plus 2/3. All right, this is why I want to go through this problem, is because we've got a lovely, lovely fraction in it. Make sure that we're all good to go. X, y. Okay, our first point is 2/3. Where does 2/3 fall here? Where does 1/2 fall? A half. Okay, if this is 1, 2, 3, 4, 1/2 of 1 is somewhere in between here and here, right? So same thing with 2/3. 2/3 is somewhere in between 0 and 1. So that's our first point. Then our slope is also positive 2/3. So when we're graphing this, if we want to get to the next points, if we start in between 2 lines, we want to continue to be in between 2 lines. We're going to go up 2 and right 3. I'm actually going to draw this up here. So we go up 1, 2, and right 1, 2, 3. That is our second dot, and we connect them with a line. Okay? Questions on that? This is the 3, this is the 2. Questions? Okay. Does everybody have that on their paper? Yes? Okay. Last example. Yay. Yay. All right. Last one. So, find an equation of a line. Whoops, find. Equation of a line containing the following points. Okay. And the points that this one contains are 1, 4, and 5, 6. 1, 4, 5, 6. All right. Yes? Yeah, find an equation of a line containing the following points. 1, 4, and 5, 6. All right. We're revisiting point slope form in this problem. Okay, so we have an x1 and a y1. So first point listed is x1, y1. The second one is x2, y2. The only difference is that now we don't have a slope. So Alyssa, what do you think? Perfect. Yes, excellent. So she said do y2 minus y1 over x2 minus x1. We have a y2 of 6. We have a y1 of 4. We have an x2 of 5. And we have an x1 of 1. So we're literally plugging numbers in and then solving them. Solving or combining them. So 6 minus 4 is how much? 2. 5 minus 1 is? 4. And then we can reduce it to 1/2. So that's our slope. Okay. So here's where we go from here. Point slope form, remember, is y minus y1 equals m times x minus x1. So we did this on our homework already. So that, remember the things that we're plugging in are m for the slope and x1, y1. Okay, so we get y minus 4 equals 1/2 times x minus 1. And then, from here, what do you think we're going to do next? Alyssa? Shugi, what were you saw you going like this. What does that mean? That's good. Distribute. So we get y minus 4 equals, let's move this up so you all can see. Y minus 4 equals 1/2 x minus 1/2 times negative 1 is negative 1/2. Okay, what would be the last step to getting y by itself? Add 4. So this is the one tricky part of this problem, is that we have to combine 1/2 and 4. How many people, okay, so let me stop there for a second. How many people would agree that 4 is the same thing as 4 over 1?
Yes.
Yes? Okay. If in order to combine these, I have to have the same denominator, that means I have to multiply this whole fraction by what over what? 2 over 2. Again, the reason we do that is because we have to have the same denominator to be able to add them together. Okay, so we get, whoops. All right, so we end up with y equals 1/2 x minus 1/2 plus 8/2. Negative 1/2 plus 8/2 is how many halves? 7/2. So it's 1/2 x plus 7/2. Okay. Are there questions? People at home, can you tell that the energy level is a little low today? For all of us. Mrs. Miller is sick. And this is the time of year that we all get sick, I think. Are there questions? Let me go ahead and write your homework up here so you guys all have it. So that, let's see, this is homework 17. Page 136, numbers 2 to 36 even. All right. Okay, so everybody go ahead and get out a book, start working.